Review of one-dimensional dynamics. This chapter assumes that you have already studied dynamics in one dimension, which describes how the motion of objects can be predicted by knowing the forces that act on them, but only moving along the x or y axis, or east and west, or north and south, or up and down were considered. Life is more complex than that. We're going to consider motion that is a combination of movement along the x-axis and the y-axis, like the children's toy Etch-a-Sketch. Either ask your parents or look it up on the web. But here's a picture of the inside of one. The metal pen in the lower right quadrant moves along the y and x axes of the rods. First, we'll review the basics of one-dimensional dynamics. The topics we are going to review are Newton's 3 laws of motion, inertial reference frames, mass and weight, forces, including weight and gravity, normal force, tension, and friction, drawing free body diagrams, and problem solving. Newton's laws of motion. The first law, an object maintains its velocity, both speed and direction, unless acted upon by a non-zero net force. This is also known as the law of inertia. This law actually wasn't put into place until Galileo Galilei proposed it in the 17th century. Why wasn't this obvious to people like Aristotle in 350 BC, who thought that an object had to be pushed continually to move? A casual observer sees objects move when someone or something is pushing or pulling it, and when they stop the push or the pull force, the object stops moving. This backs up Aristotle's view. So the first law really is counterintuitive, unless you think about the other force that's acting on the object being moved, the force of friction. This force always acts to oppose motion, so once you stop pulling or pushing the object, it will soon come to rest because of the friction force. This is what Galileo and then Newton recognized and codified.